Good morning, everybody. This is our third day of the conference. I'm Helmut Klug. I will be chairing this session. We have three speakers today who will be talking about digital food history. They will show us how digital research methods can be applied to medieval cooking recipe texts. The question moderator for today's session is Virginie. She will explain to you how discussing in this online conference works.
Good morning, everyone. So I'm your Q&A moderator today. I'm waiting for your question in the bubble Q&A below the screen. Don't hesitate to use it during the session, and I ask after the session with your question for you. I will come back to you and the end, and I make the question for you. So see you later.
Thank you very much. The first speaker of today is Christian Steiner. He is a doctoral researcher at the Center for Information Modeling at the University of Graz. His focus is on digital humanities in general and semantic web technologies in particular. Currently, he is the technical mastermind behind the CoReMA project, and he will tell you in his talk about what we can really do with semantic web technologies. Christian, the chair is yours.
Thank you very much, Helmut. I hope you can all see my screen now. So I'm going to tell you what we did in the CoReMA project with linked open data and with our medieval cooking recipes that we worked on in the CoReMA project. So first off, I probably have to explain what linked open data is. Well, linked open data is what you can see here. This is the so-called linked open data cloud. It's a visualization of the data sets within the greater linked open data cloud. And this cloud has been growing exponentially since 2007, I think. And it looks somewhat like this at the moment, but it's very hard to visualize at the moment because it's grown so big. So there's loads of different domains in there. As you can see, the life sciences play a big role. And I'm going to explain what this is all about. So it all started with this man, Tim Berners-Lee. He's the inventor of the World Wide Web. And he's also the inventor of the Semantic Web. And as early as 1999, he said that he has a dream for the web in which computers become capable of analyzing all the data on the web, the content links and transactions between people and computers, the day-to-day mechanisms of trade, bureaucracy, and the daily lives will be handled by machines talking to machines. And that's the key word here, machines talking to machines. Now, that's what linked open data is all about. It's all about machine-readable structured data. So the semantic web goes away from linked documents as we have known it with the standard World Wide Web. It goes on to be a web of linked data instead of linked documents. So that's where the name comes from. Linked open data gives us the notion that the data that we expose should be open and publicly licensed. But this is not a necessity, but it's a wish. And it's something that we should all aim for. So the whole technology stack behind this is graph-based. So we have to visualize a huge, giant global graph instead of a World Wide Web, as we have known it before. Now we can envision a giant global graph, GGG, instead of WWW. Some people also call it Web 3.0, but there's more synonyms out there. But the notion of semantic web and linked open data is the ones that you will hear most often. So we go from linked documents to linked data. How do we do that? We have to store our information with a special structure. And this special structure is called RDF, Resource Description Framework. And this structure allows us to store data in so-called triples. So triples are very simple sentences, so to say. It resembles human language a lot. So I could say Christian is a person with this statement here. And this statement is human readable at the moment, and also machine readable, more importantly. So this means Christian is a person, and all of these classes and this property is unique. It's uniquely identifiable by machines. So how do we do that? These classes here represent a whole URI, like we have it here. We have the planet Mars, and we have the chocolate bar Mars here as two distinguishable different concepts. And these concepts are distinguished only by its URIs, because the string of Mars is both the same. So if I don't give you any context, even humans couldn't tell whether I mean the chocolate bar or the planet. The W3C defines all these standards that are necessary to do so and to make heterogeneous applications communicate. So in CoReMA, I hope you're all familiar by now with our project. What we did was we went from the right side here, from a recipe within a recipe collection to, in the end, RDF statements. In between, there are a lot of steps, and the base unit we used was TI XML to store our information and to transcribe it and to annotate it. But then we used transformations to transform all this information into structured RDF statements so that they become fully machine readable. And why did we do that? Because we want to create a giant graph that also reaches beyond CoReMA. So what we see here is exactly the same as what we see here in the code. All these RDF statements are basically a graph. And they're also stored in the so-called triple store as graph data. And this means connections are very easily made with other data that uses the same domain, and they use vocabularies that can attach to our CoReMA data. So what you see here is a visualization within the triple store. And you see this one recipe called B2.1. And this is the idea of the recipe. And we can see this recipe has tools, it has ingredients, and so on. And we see one ingredient here is sour cherry, and sour cherry again has edges within the graph to other recipes, because they also contain sour cherry as a recipe ingredient. So this is just for you to visualize our data, so that you can imagine how the graph reaches out. So we don't have closed information anymore, but we can reach out to all kinds of different positions within this giant graph and navigate our way through it and find information that we didn't know existed before. So what we also have is all these different labels for sour cherry in different languages, of course. So we have a whole lot of early New High German denotations for sour cherry. So the way it was written was very different. So we have about 47 here. And there's the extreme example here is apple, where we have over 100 different ways how to write apple. And we have all this information stored in the triple store. And I will show you later that we have even more than just the information that we collected in CoReMA. What we can do now, once we have this information in a structure like this, we can start asking questions to the data, and we can start asking all kinds of questions. And we have done this. We're not at the end of asking questions. We probably will never be at the end, because we always come up with new questions. And most of the questions can really be answered by a pretty simple query with the query language Sparkle. This is how it looks like. And what we then get from the data is not only tables or raw data, but we also get visualizations like this. This is one example of a statistic that we made as the percentage of food groups in the different collections over time. So we have beverages here from 1345 to 1497 at the moment. There's going to be a lot more data coming to the CoReMA website soon. So the more data we get, the bigger this graph gets, the more information we have, but the query stays the same. So this is basically, it will grow automatically by just ingesting new triples, new statements, new information to the triple store. This is the view of the CoReMA website that will go online soon. So this will be the next update where we will provide indices in statistics and an API for all these structured data. And this is just a means to an end, because obviously we can basically have endless statistics about medieval recipes, but this is just a collection that we found most useful. And other people can obviously take the data and go from there and work with the data by using our API, and in that way reusing the data, which is an important aspect of our project. So we get our answers, and we can get our answers in different ways. We can get our answers as tables, visualizations, and most importantly for me, but probably not for you, raw data. Because raw data is one of these principles in linked open data. Everyone needs to expose their data as raw data, because this is how computers can communicate. This is how we can reuse data efficiently. And not just any raw data, but we should expose it as RDF in any of its serializations. And RDF has a lot of different serializations. So one of them being JSON, as you see here. But this is just one way of exposing the data in a meaningful way. So there's just another example of statistics that we get out of the triple store with a Sparkle query. And here you can see just the percentages of the top ranked ingredients in the different collections. So we can see that a lot of chicken, egg, and wine and spices were used in our recipes. We can also see the difference that is sometimes quite big from the respective collections. We also have geographical data in our CoReMA datasets. we have information about languages or dialects, at least for the German, early New High German recipes. We have this dialect data, and we could visualize that. We can also visualize on a map the repositories where all the manuscripts are stored today. We also have temporal data, and we can visualize that in the timeline. So this is what you see here are basically just different representations of these statements that we have in the triple store that I showed you before. It's all part of this giant graph, and we sparkle it, we query it, and get these representations. But for me, most important part of why we are using linked open data, why we are using RDF and the triple store instead of, let's say, a relational database or just XML and not beyond that, is because the graph reaches beyond CoReMA, and not because we added some information from other databases. No, because the links go outside, because we decided to use Wikidata links, Wikidata IDs for our entities, being tools and ingredients as the main entities. And so in this way, we automatically created a way bigger graph than we would have if we just used the CoReMA data. And there's nothing else we have to do but use this keyword service in the Sparker query to now query different databases as well, like Wikidata. This is one example where I can ask a question like, what is the current carbon footprint of the ingredients mentioned in the CoReMA recipes? We definitely didn't include anything like that in the CoReMA project. We never asked a question like this during the project time. It's none of our interest, but the information is there. Why is it there? Because we used linked open data. And so I can, just for fun, if I want, I can do that and find out that in 2019, an apple had 0.3 kilogram of carbon dioxide equivalent per kilogram in Germany. So this is information that was definitely never recorded in the project, or should be, but it's there and we can query it. And so it opens up a whole level of reusing the data. By mentioning Wikidata, I have to explain to you what it is. Wikidata is basically boiled down, it's Wikipedia for machines. It's language independent. That was very important for us, obviously. And yeah, that's what it is. That's the information that you need to get the idea. We can also now get labels in a lot more languages than we have. So now we don't only have the over 100 different early New High German versions of Apple, but we can also get all the Arabic labels for our ingredients in CoReMA, even though we never recorded anything like this in the project. It's just there because we have the connection outside with the graph. And so I can do this query and get the Arabic labels for our ingredients. So I'm coming to an end now, and what I need to say is that more data needs to be exposed as RDF. If we had more data exposed as RDF, we could do all kinds of very interesting things with our data. This is one example from what we did a couple of months ago for the Oxford Food Symposium, where we used data for the taste and flavor of different ingredients to create flavor profiles for our recipes, for our collections, and parts of collections. And so I have to admit, we couldn't do that automatically because there was no such data exposed as RDF, but we had to go the way and do it ourselves and transform this flavor data into RDF. If people out there who record such flavor data would go the way like we do and expose their data as RDF, instead of just putting it in a relational database, it would be way easier, as I showed you here. It would just need one service tag and in the query that we could get information like this here. We wouldn't have to go all the way and do it ourselves. So this is where the future should bring us. People should expose their data as raw data, as RDF data, so we can do things, we can reuse our data. And so this is where the future lies. CoReMA could be at the center of the linked open data cloud. We could start from one ingredient and reach out to all kinds of different domains and get all this information. And I hope that one day we're going to be at a stage where this will no longer have to be discussed, but it will just be a fact that things are like this. Thank you very much.
Thank you, Christian. I believe we do have some questions.
Yes, we have one question from Marion Lamé. She asked, "Hi, Christian, and thanks for this highly pedagogical presentation. Would you kindly repeat what you say about the raw data, explaining what raw data is exactly with a couple of CoReMA examples? And insist again on how important this data is for computer system, please."
So, okay. So if I understand correctly, Mario asks for examples for what raw data is. So raw data can be in a lot of different serializations, but raw data is basically something that computers can understand. And if I can just show you a quick example here of the raw data that we use, it's stored so I hope you can see. This is raw data in an RDF serialization, in an XML RDF serialization. But RDF can also be stored as JSON.
Excuse me, maybe you want to share your screen?
Oh, the screen is not shared anymore, okay. Sorry. I didn't stop the screen sharing. So do you see the screen now?
Yep.
Okay. So this is XML serialization of RDF. And this is basically how raw data looks like. It doesn't really matter if it's XML or JSON or Turtle or any of the other serializations. If I can show you a JSON serialization quickly. So for instance, so this is a JSON serialization of a Sparkle query, and this is what raw data means. It's just meaningful information for the computer, not for the human. So if I can show you Wikidata quickly. So they have a human readable interface. We have an apple here. So this is human readable. But behind this is raw data. As you can see here, these are statements. An apple is a subclass of fruit or food. An apple has this image. And the computer can understand it because it's stored in raw data behind this beautiful human readable version of what you can see. So I hope this answers the question.
Thank you. Marion Lamé tell that raw data is machine-friendly data. Is you okay with that?
Machine-friendly data, yeah.
Perfect. So next question is from Antoine Soulier. He asks, do you think it's possible to recognize grammar aspect of recipe?
I don't really know what Antoine means with grammar aspects. So maybe he could go grammar in the sense of linguistic, the linguistic phenomenon. Probably.
Yeah. Yes, probably, because his second question is also discovery aspect of recipe. I mean the way to recipe is writing. So yes, grammatical.
The way the recipe is written.
Yeah.
I have to admit, I don't really understand what is meant by that. But linked open data, it's not limited to one aspect of anything. So it can be applied to any domain, also the linguistic domain. So there is actually on Wikidata, a lot of linguistic aspects are already covered. And there's ontologies that are explicitly dealing with a linguistic aspect of any text, also including recipes. We didn't especially focus on this question of grammar or other important linguistic aspects, but this is definitely possible with linked open data, and it's done a lot. So the linguistics play a big role in linked open data and gets bigger and bigger. I hope this answers the question.
So thank you, Christian. I don't have more questions. See, just one. Stunning insight, thank you very much. How does the translate from document to machine-friendly data work for the large-scale database? Is it automated?
Oh yeah, it's automated. So how does the translation work? The translation processes are done with different algorithms. As we record our data as a base format in XML, we mostly use XSLT as a transformation language, but you could possibly use any programming language. We also use Python to do some of these steps. But in the end, most steps are realized, most translation steps are realized with XSLT. And yeah, this is how we transform it to the final RDF format that we needed.
Thank you. And now I have another question. Have you tried to generate STEAM data on the basis of your data, showing the closeness of recipe collection? How do that work out?
We didn't use this concept of generating stemmata to show the closeness of recipe collections, because this would be to reduce, this would be an approach that reduces the recipe data to just linguistic phenomena. And we didn't go this step, but it's definitely one thing that we could do. I created an index of similarity with our triple store, but didn't gain really great insights because of the different orthographics we have in early New High German and other problems. This is an approach that we would try out probably in another project, but not within the CoReMA project. Within the CoReMA project, we definitely focused on the semantics in the annotations that we did as humans, and annotated ingredients, tools, dishes, and so on, and didn't reduce the linguistic data to its standard form, or to try to do any insights of that. But it's an interesting question, and it would need a whole other project, I think, to do this in a way that it makes sense.
So if I might add to this answer, we are working on the question how the German medieval recipe collections are related, but we are not doing it with the classical editorial methods like stematology. As Christian said, we are working this angle from a semantic point of view. And we do have already data on the website that shows which recipes are related to each other.
And now I have a question from Bruno Lolu.
Yes. Do you hear me?
Yes.
Okay. Maybe I can put my camera. Yes, I was very interested by the talk of Christian. This is not the first time I hear him, of course, but there's always new things appearing, and it's very interesting. For example, the question of carbon footprint is very exciting because it can be an argument to say that you need to eat and to cook medieval way because it's good for the planet. So if you can have that, it would be interesting for our way to valorize what we do. Also very interesting is the question of dialects, because it's a clear important point in the German culinary production, but it can be also for French, for example, or for Italian. So it's important to keep that in mind. I perfectly agree with this question. The question of repositories is, for me, it's less important because it can be simply a chance and so on. Maybe in Germany it's more stable, but for example, in France or in Italy, manuscripts can have migrated all around the world. So it's very difficult to have a reflection or an argument on this subject. And the question, very important question you spoke about, you and Helmut, about the question of stematology and the relationship between the manuscript and the manuscript tradition. It seems, as a first glance, that in the German culinary production, the manuscripts were often very different, each from other. In France, there is, for example, one big tradition, which is the Viandier, with differences between the manuscript, but it's more coherent as a tradition. But we decided for all the CoReMA program to have the reflection with manuscript. Manuscript in the unit, and inside manuscript, the recipe is the unit. This is, I think, the originality of what we do. Maybe there will be in the French production repetitions from manuscript to manuscript that can change, in that case, the statistics. Maybe after we can correct it in another step, but it's not the case now. But it's interesting to have this reflection on the level of the recipe and not on the level of the collection of the tradition. So it's really interesting, and this is, in my opinion, the deep originality of CoReMA. That's why we organize a conference on the recipe, because our unit is the recipe. So thank you very much, Christian.
Thank you, Bruno.
I'm happy to work with the Graz team, which is efficient, and we surprise me every time.
Yes, that's our job, or part of it anyways. Okay.
Thank you very much.
I believe there are no more questions for Christian, so we will move on to our next speaker, which is Denise Ardesi. Unfortunately, her technical setup will not allow her to be on screen with a camera. She is phoning in. And maybe Christoph will be sharing her presentation. But first, some words about Denise. She's a doctor of French literature of the Center for Advanced Renaissance Studies at the University of Tours. And in the CoReMA project, she was an engineer in analysis and criticism of historical and textual sources. So, Denise, the floor is yours.
Hello, everyone. I hope that you can hear me. You can see my screen now, maybe. Okay. You can see my screen. Okay. So, hello, everyone. Today, I'm going to talk about the road that manuscript takes to be transformed into a scientific digital edition. Our journey will be done in 3 steps. First, we will try to clarify what a scientific edition, digital edition is, and to do that, we need to think about what a text is, especially if you want to edit it. Also, it's important to keep in mind that editing is deciding. Secondly, we will discuss about what we should know to make a scientific digital edition. Of course, when you think to digital edition, you say encoding. Yes, but what does encoding mean? And especially in which language? Finally, I will tell you how we process the data in the CoReMA program project and show you an example of scientific digital edition of Middle Ages culinary manuscripts. So, let's start our trip. Before starting a scientific digital edition, we have to think about its primary purpose, as I said before, the text. So, what is a text? Patrick Zale, professor of Digital Humanities, has published a will that helps us to answer the question. According to Patrick Zale, the text is the support of an idea because it conveys an intention. The text is also a structured work. It has a specific structure behind some linguistic code. It is divided into paragraphs with footnotes, cross-references, etc. The text is a linguistic code. It is expressed in one or more language. The text is also a version. The text is also a document, is a visual sign. It can be seen as a visual phenomenon that sometimes carries semantic information directly. We can express all these characteristics of a text in a scientific digital edition. However, when we want to make a digital edition, we have to choose which aspect of the text we want to underline and which of these aspects to overlook. Maybe because of time or budget of the research program. Therefore, we make an important choice that will guide our reading of text. That is why I said earlier, encoding is making a choice. So now we try to understand what is a scientific digital edition. It is a question that has been discussed a number of times and requires a long-term reflection. Here, I try to summarize the very basic points in order to understand its core concept. A digitalized version of a real object, such as a facsimile, manuscript, or scan book, is not a digital edition. I insist on this because sometimes we are not able to make a difference. So it's not a digital edition, a digitalized version of a real object. But digital scientific edition is a scholarly digital edition guided by a digital paradigm in theory, method, and practice. Distinguished researchers have created a label, Critics Digital Edition. This is the XIIe, so German, in the IDE Institute, which brings together researchers in the field of digital humanities who specialize in the application of digital methods to historical documents. Now we move on our second part of the presentation and try to understand what it means to encode. With a more general overview of a digital scholarly edition, we can now move, as I said, in our second point, so understanding how to realize a digital scholarly edition and what is required. And so the answer is simple. What we have to do if we want to make a scholarly digital edition or scientific digital edition, what we need to be done. We have to encode. But what does encoding mean? For example, in our daily life, when we wrote something, we use diacritical marks on paper, and that is encoding. So the interpretation of word and sign in a text is not random. This interpretation is guided by punctuation marks, by font changes, by their special arrangement, by right brackets, etc. So to express and represent this information, or even more, in a computer system able to process this text, a markup becomes essential. The markup is used to express our previous reading in the time into the machine. So it's a part of the encoding. Okay, but moreover, the encoding makes explicit, for example, the structure and the signification of the document as a considered relevant by the editor, as well as the different readings, lesson, and interpretation. A digital document is therefore more than a sequence of encoded characters. It has a structure and a meaning that can be perceived by the machine. A document can have several different readings, and each one is relevant to retain and represented in a digital scientific edition. The scope of a document can be enriched by annotation, then be encoded. A code is a convention on which the editorial decision are structured and represented. Encoding is the first and the most important part of our digital editorial work. But we have one problem. In which language should we encode? We choose to encode in XML-TI because, as you see here in the screen, TI allows is independent first and allow us to apport some changes. Is designed by a scientific community, and the TI facilitates the creation, the exchange, the integration of textual data. So I hope that now you have idea more clear what is to do a digital scientific edition that is not just digitalized books and put it in a website page. Okay, so if you are more interested on TI language, you can see the link, the guidelines, and discover this beautiful world of TI language. Yes, for the CoReMA project, so we move on our third part. For the CoReMA program, we have established a specific workflow based on Brett's schema published in 2012 in his book about digital humanities pedagogy. This is the CoReMA workflow of French side. We start, as you see here, we start from the source, which are our manuscripts. We transform them into a machine-readable transcription. We transcribe the text in Word with some specific rules that I will show you in a moment, the rules. Then we move on the data representation phase, the encoding, as we talked about this before. The encoding of the text is in XML-TI, is done in Oxygen software and through a new encoding and through a new computer tool named Heterotoki. We agreed with the Ocean team to have a common editing of working expression because we are working just in time. We agreed with the Ocean team to have a common encoding schema and which I will show you later. You see here, in this part, we have a circle of encoding and editing of working expressions because we are working just in time. In other words, our work file that has been transformed into XML language travels between the Oxygen software and Heterotalkie to allow us to refine the markup. This cyclic journey is composed of an alternation between encoding and rereading of the culinary text, paying particular attention to the recipes and the categories chosen to query the recipes. Finally, you see here at the end of our schema, finally, once this cycle is completed, the file is ready to be sent to a website of the CoReMA program and become a scientific digital edition. We can then visualize and query it as Christian showed you before. Now let's take a closer look at the workflow. So first step of our workflow. First of all, we have our sources, the manuscripts that Professor Loriot has already presented in the first section of our symposium. Then we transcribe the manuscript, and for the transcription, we have made some choice on the transcription that you can see here. For example, we keep the indication and folio changes, we do not modernize the punctuation, etc., etc. So, as I said before, making a digital edition is making a choice. So, we choose how to transcribe the manuscript, for example, what we want to keep and what we want to not to keep, which way we want to present our transcription, which way we want to present manuscript, because if the scientific digital edition is oriented in a linguistic point of view, we make some decisions that are not the same if it is a semantic direction or other. Okay, so we can ask what we can ask of our scientific digital edition. Christian showed you before, but here is our analysis model. So we can ask, of course, the title of the recipes. We can ask the dish. We can ask the ingredients. We can ask about the tools. We can ask about kitchen tips. And this is our model for data representation. It seems interesting to me to show you in practice how we did to build the markup. Several ways were open to us, but for precision and scientific accuracy, we chose to use a new software. The name is Heterotalkie. Heterotalkie, here you have the link if you want to go to explore this new software. Heterotalkie is an online service of scientific and digital edition of the work expression of a research project. It was designed by Marion Lamé and Federico Poggio from the Istituto di Scienze e Tecnologie dell'Informazione of Pisa, Italy. Here you see we have a synoptic table of concordances that present the references languages. Fro, it means ancient French, the language of expression of scientific editor, French, the pivot language, English, between the different systems. Other information appears, such as definition, Wikidata, semantic structure, and lexical coordination from of tokens. As Christian said before, despite the apparency, Wikidata is not Wikipedia, and it's better to underline this. If they work together, they should be distinguished. The importance of the Q numbers is that the importance of Q numbers, you know already, so I move away. So I would like to take an example why we chose this software, because, for example, the token filon, this is an instruction. This instruction is difficult to translate. So we have decided that filon is a technical loan because we do not have a suitable translation in contemporary French. I mean, yes, we can translate, but not with only one word. We have to translate with a phrases, with a lot of words. So we say that is a technical loan, and in English we have translated just poor because it is the pivot language. Heterotalkie, in this case, allow us to give a definition that they explain the term in question. Indeed, in French, to define the meaning of this lemma, we use a periphrase to define the lemma. As you see here, verser délicatement en un filet. So pour delicately, okay. So here we see that the CoReMA part of in the CoReMA program, we also study and question about the meaning of each word. So this is very important for our philological and codicological analysis, because you see here, we can see the definition, as I said before, and also we can put some notes. And for example, here it means that XIIe was an error of a copyist. So it's important if you want to analyze manuscripts in a philological or codicological way. For example, it will be possible to query it in the computer system and compare it with other errors that maybe occurs in other manuscripts. Moreover, we can also see all the graphic variants of the action to pour. Of course, all this work on a lemma is very useful, not only for lexicological, philological, and comparative studies, but also for exporting it in a PDF and for footnoting in a paper edition, maybe. If you want to put a digital edition in a paper edition, I come to this point later. This work is certainly long, but it guarantees a scientific accuracy. Since we work with the Austrian team of University of Graz, we can also establish a lexical and semantic coordination between medieval French, Old German, and this is possible thanks to the work done in lemmas, in token, and through the Wikidata. As you can see, the concept Apple is expressed with Q numbers, and it is present in the references languages, for example, French, pomme, the language of expression of the scientific editor, French, and the pivot language, English, and we also find the orthographic variants of Old German. So we are now at the end of the encoding process, and we can publish our text on the CoReMA website. Now that you have seen the work we do for each text in our corpus, so I will show you an example of a manuscript for which we produce a scientific digital edition. This is the Viandier de Taille-Avant manuscrit d'édition. Here you can see, so you remember at the beginning of our meeting, I told you that I talk about the road that a manuscript takes to be transformed into scientific edition. So here our manuscript, you see, this is the beginning of the Viandier de Taille-Avant manuscrit d'édition. After that, we translate our manuscript in the XML-TI code, which allow us to generate the digital edition. And finally, the scientific edition on our website. So you can see here, it's very easy to understand how does it work. You can push the button ingredients and all the ingredients appear. You can push the button dishes and all the dishes appear and so on. But in that now, if you go to the XML to the CoReMA website, you see you know how this work was being done. And in conclusion, I like to underline that scientific or scholarly digital edition offer an opportunity to overcome the limitation of print technology. The new possibilities have a fundamental impact on the theory and methodology of a critical editing in general. I mean that we cannot think in the same way if we want to produce a paper edition, a printed edition, and online edition, and almost and a scholarly digital edition or scientific digital edition. To sum up, edition always starts with material documents, the same material document. In our case, French and Latin manuscripts, culinary manuscripts of Middle Ages. But digital editions are essentially different from printed edition in their content, structure, and rule. Of course, they share the same subject and have the same goals, but digital editions display additional specific characteristics aspects. The praxis of preparation and the methods applied is different because digital editions follow a digital paradigm. In fact, for my opinion, a digital edition cannot be given in print edition, in print, without a significant loss of content and functionality. So thank you for your attention.
Thank you so much, Denise, for this very interesting talk. And for the moment, I don't have a question for you. Maybe Helmut or Bruno.
My talk was just to underline the difference between a paper edition and a digital edition, and to underline and to show to everyone to how a digital edition works, the work of to make a scientific digital edition. So.
Thank you, Denise. Thank you very much. It was a very interesting insight in the working process of the CoReMA project, and it gives a very nice roundup for this session here.
May I ask some question, Helmut?
Please go ahead.
It's not a question, in fact, because I know very well the work of Denise, and it was a very clear presentation, very pedagogic, and we understand, in fact, the work in progress. The work is still in progress. It's not completely finished. So we have so many things to do. But I wanted to tell that Denise has managed a staff of team of many people, many trainees and partners also. So I want if you want to name them under the Denise direction. There was Corentin Poirier, of course, and also trainees like Manon Vell, Astrid Levitt-Müller, Laurine Gobert, Alan Muslim, Anas Belfatmi, many trainees. And I asked them if they hear this conference. I'm not sure, but it will be recorded so they can have this satisfaction. And also our partners from Italy that you named also, Denise, Marion Lamé, who already asked some question, and Federico Ponchio. This is all this team which take this this task, which was complex and which is not completely finished. Thank you very much to all, and to you particularly, Denise.
And when we speak about Marion Lamé, she has a question. How could a project such CoReMA could consider to insert in the workflow some crowdsourcing, multiply editorial proof, reading, and some data? For instance, they see several types of possibly integration or translation.
Okay, but we can I think that we can integrate it, and we will discuss the way to do this together. Voilà, that's my answer. Because as Bruno says, it's work in progress, so we have to work together, and we will decide how to manage that.
And now Marion Lamé has the point of view of Christian about the same question. Christian, are you there?
Yeah, I'm here. I need to reread Marion's question because it's a bit complicated. I would say it's possible, but not within the scope of the CoReMA project as it was planned. So for this kind of crowdsourcing, I would say you'd have to plan the project in this way all ahead. Like you can't do this in the middle of the project, but you have to plan it out in the way, and then you have all the problems that come with integrating crowds into annotating data. It's not an easy question to answer, and it's not an easy question to tackle. It might solve some problems, but it might generate problems at the other side. What it basically boils down to is that we need resources, and in order to generate useful data, we basically need more resources than we have at the moment. And this is the core problem. This is why we keep thinking about, what if we ask a lot of people to do this for free? Yeah, it might work to some extent, but it's not the core problem, actually. The core problem is the lack of resources that we have in our domain.
Yeah, if I may add to this, there with crowdsourcing scholarly tasks comes the problem of verifying the correctness of the data. So you again need scholars to look at the data quality. So at some point you need to make a stop, either if you don't have time or if you don't have money or whatever reason. And the important aspect is that you have to prepare the data you're working with in a way that you can add to it in the future. And this is what digital food studies, I think, probably provides best. So for example, in the CoReMA project, we have the Humanities Asset Management System in Graz, where we can provide versions of the data files. So at one point we consider, okay, this file is finished, we publish it. If we have to do this publishing in the middle of a discussion process because we have no more time for further discussions, but we have to publish it, we can say, okay, we publish a version of the data, but in the future, we can add to this version and make it even better or change it. So this would be, I think, another version how this could work. Okay, being chair, I have to look at the clock, and I think we have to move on. Thank you, Denise. Thank you, Christian. Thank you. Thank you for the questions that have been asked so far, and we will move on to Julia Eibinger, who will be presenting the CoReMA data model in a slam, which is actually a very short presentation of a very, 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 very big problem. But with no doubt, she will master it perfectly. She is a student of the Digital Humanities master's program at the University of Graz, and she is a student assistant to the CoReMA project. And for the last year, she hasn't been doing anything else than working with this data model. So Julia, please.
Thank you for the introduction. I will share my screen to my PowerPoint. Yes, you can see it now. Yeah, I will be talking about the annotation of cooking recipes using the CoReMA semantic model. As you know, the objective of the CoReMA project is the comparison of cooking recipe texts handed down in various different languages, namely, in our case, the early New High German, Middle French, and medieval Latin texts. And so we aim to find out about recipe as well as collection relations and the potential migration of texts. Oh, I need to change. These ambitious feats can be accomplished by utilizing the possibilities digital methods have to offer. And this is where the CoReMA semantic model comes in and why I want to present it to you. In the project, the semantic annotation of text passages, phrases, or single words in the recipes lays the foundation for the comparison of recipes in different languages. This is essential because it means that a normalized XIIe version of the transcription is marked up according to the CoReMA semantic model. So you have to stick to it to actually achieve anything useful. Thereby, you enrich the text elements with semantic value, which is machine readable, as Christian already presented to you. You can see here the facsimile of the Kochbuch des Meister Hans, as well as its XIIe already marked up. The semantic enrichment is crucial for the comparison beyond language barriers. By adding a standardized value of the spelling, we make it clear for anyone, even someone not capable of understanding the original text, what semantic values are present in the cooking recipe. The current workflow consists mainly of two parts: the manual annotation of the macrostructure, during which phrases or single words are tagged by hand. This is still up to cognitive work and decisions of the human scholar. This step contains elements which describe instructions, various tips regarding the cooking process or preservation possibilities, as well as dietetical information and so on. The microstructure then, the second main part, consists of ingredients and cooking tools, which are mentioned in the recipe text, and their spellings are annotated automatically using a Python script, but the annotations have still to be reviewed and corrected where necessary, because you have to clear up ambiguities that are present in historical texts, as we all know. And the computer just doesn't know which one is the right one. How could it? Here you can see the same visualization of the CoReMA semantic model, which Denise already showed you. The model provides all elements which are used to annotate the recipe text in the CoReMA project. And wherever possible, elements from the TEI namespace were used to accommodate the recipe texts. And just so that we can also accommodate relevant conventions in the DH community and stick to already established standard. But because recipe texts have not yet been taken into account by the guidelines, elements close to the sphere of cooking and household were added and are now the main part of the CoReMA contribution. The model is being adapted and expanded throughout the projects, so we can accommodate various text realities as we encounter them during our work, and each element resembles a single distinct semantic value. The ingredients and tools play a central role. They are the smallest common elements upon which a recipe text can be compared to another one. And additionally to the element tag, they receive a corresponding Wikidata concept ID, which you have also already heard about today, which links the spelling to the specific concept. For example, each spelling of apple corresponds to the same Wikidata ID, which is Q89, making it processable for the machine, what is already clear to us, namely that the mentioned apple in the various different spellings that we have always points to the same concept or idea of an apple in reality. We have also decided to depict exclusions and analogies of specific ingredients in the text. For example, exclusions of specific ingredients like fish scales, which might at one point be used to make aspic and in another may be discarded. The attribute analogy refers to making something out of something entirely different. For example, making partridge out of fish. In this way, there is a fake dish created, but no actual partridge meat is used. By annotating this analogy, for one, we don't falsify our own data. By leaving it in as is, it would suggest that in the cooking recipe, partridge is instead used. But we also make analogy ingredients trackable throughout our data. So we can now ask and answer the question like, which ingredients are most commonly used as analogy? So at the moment, the most imitated ingredients are partridge, eggs, morels, and roe deer. Obviously, the CoReMA semantic model has been created while working with the early New High German, medieval Latin, and Middle French recipe texts, but it is designed for much broader future use. By using the CoReMA model, annotation of any recipe written in any language or dialect and in any geographical region and during any time period is possible, even of historical texts rich in spelling variations and ambiguity. The annotation method enables comparative analysis for any text corpus, potentially covering a wide range of languages, time periods, and regions. The use of such models would offer possibilities of subsequent use of research data, and the active exchange between researchers and their communities can be further supported. Thank you.
Thank you very much.
At the moment, we don't have any question for you, Julia.
So maybe I should ask a question, but possibly I know the answer to that. There's one thing that keeps creeping up with me when I use the CoReMA semantic model to annotate the texts, and therefore I know the workflow Julia is applying to the text. So talking about the workflow, do you think it is worth the effort?
Yes, of course.
Why?
Because I think annotating the text in this way offers a completely new perspective on it, because you have to interact with the text in a very special way. You have to think about each phrase and each text snippet because you have to decide what does the text actually, what is the semantic value that the phrase holds and how does it interact. So I think alone in the way that you have to actually really think about it and decide for each step of the way, what do you want to do? It's essential, and it offers a new perspective. And also it's, for me, always very interesting to actually talk with you or Barbara about the possibilities that come up throughout annotations and the different ways that you can actually apply elements, because especially in the macrostructure, it's not always so clear cut, but it offers a very good starting point for a dialogue, I think.
Okay, thank you.
Now I have one question. I'm interested in knowing how you address terms that have a double meaning, in which one is a food and another not a food. Also, how have you dealt with any ingredient name that cannot be identified?
Yes, so usually we have, because there are so many spelling variations, we have also many words in our list or in our lexicon that can mean an ingredient in one point and mean a word, for example, in another context. So this is why you always have to check the annotations. There's just no way around it. You have to check the ambiguities. They're already there. And so we also have we have an attribute which is basically warning. This word might mean something entirely different in another context, so that we don't stumble over it and might not find it. It happens, still happens. The ingredient names that cannot be identified, well, at first, we try to find other sources for it, but if we can still not identify it, there's no way around it. We have to assign an unclear element so that we know we cannot identify, and most times we also give a note so that the reader can knows that we don't know, and maybe they want to get in touch and let us know because they know what ingredient it is.
Thank you, Julia. Now I have a question from Bruno Loriot.
Thank you for your presentation, Julia. And for me, it stress the question of how to apply the CoReMA semantic model to other spaces, other times. That's what you said.
Yeah.
And I think we have to keep in mind some European countries where there were many cookbooks published, for example, Italy or England, of course. This is our priorities, I think. And after, also, I believe that Arabic texts need to be inserted in our system. And I want to know what you think about it. Would it be easy? Can we do to facilitate this objective, which is for me very important? And I add two new points. Through the ages, the question is to use printed text or not. There is really big stock of modern manuscripts in the 16th, 17th, 18th century, which are not used usually, except in the project, the American or English project that we know. And also the third point, so that's work for the next 20 years, maybe won't be enough. There are other kind of recipes, not only culinary, but food recipes in a large way, and maybe other kind of recipes, I don't know, alchemic recipes, etc. So we can imagine many enlargement. What do you think about that?
So I think because the purpose of the semantic model is to be applicable to a wide range of recipe texts, independent from their geographic region and time, as long as you have persons that understand the text, can read the text and grasp the semantic information, it is definitely possible, because we can use elements that are already present. And if we encounter something that is indeed unique to other manuscripts, for example, Arabic. We can also always incorporate these into the model as we do right now. Sometimes we encounter something in a manuscript that was not present in any other, and we have to accommodate that because it is a work in progress. We're still working with it and we're refining it. So there is, for me, I don't see a real reason why this should not be possible. And it offers a very, I think, very low level entry point for comparison, because as long as you can read the text, you can try to annotate it. So for me, this was my entry point in the work with the culinary medieval texts. And I found it very, very pleasant because it was just nice to interact this way, to have a clear workflow and know what you are searching for. So I think I don't see a reason why this should not work.
Yeah, if I might add to that, the primary aim for building the CoReMA semantic or annotation model was to build a model which is open for different kind of recipes. So for example, art technology, medicine, household. And as I have outlined Monday morning, the recipe is quite stable over the centuries. The main information is there. You need maybe the title, you need the ingredients, you need some instructions, and this information you have in all of the recipes, maybe in a different form, which would have to be tackled by the modeling of the text, but for the semantic model, it's the same actually. So yes, the model is open for different geographic and language areas and for recipes from different times.
It's a good news.
Yes, we build for the future.
Thank you.
Now I have a question about the size of the corpus. Is it okay for isolate receipt, or we need a corpus from a size to be okay for the effort of the annotation with the CoReMA model?
Sorry, I don't see the question.
In the first one for Martin Mand.
Ah, yes.
Following of a new question.
Yes, from what corpus size is it worth the effort? So yeah, sorry.
if I might take on this question, if you are annotating cooking recipes, you are adding to a corpus that at the moment is contains 60 collections and about I'm talking let's say 80 collections for the CoReMA project and about 8,000 recipes to which you would add and with which you can compare and which data you can use. So in regard to cooking recipes, the question of the corpus size is not relevant anymore, I think. If you start annotating medical recipes or other kinds of recipes, it would depend on the research questions you want to ask. So we are nearing the end of our session, and I once again want to thank the presenters, Julia, Denise, Christian. Thank you, Virginie, for the Q&A handling. Thank you to the audience. I have to make some announcements. One is that the session has been recorded and it will be available on the CoReMA YouTube channel as soon as possible. And for the session of this evening, we are going to hear about markets and mediators, food and cooking outside the world of cookbooks. Thank you again and have a nice day. Hopefully we will see each other this evening. Bye-bye.
Thank you.